或者多久延迟？嗯，我不知道。我刚刚说了，就是那就差不多刚才那时间嘛，就是我刚刚打开的时间，大概半分钟吧。半分钟，1分钟。我中午吃饭吃多了，有点困。Yeah. Yeah. T'inquiète, hein, tu peux prendre un version de slide. Tu peux faire une note et pour les slides, tu peux noter quelle page tu auras de questions et tu peux demander des réponses sur les slides. Super. T'inquiète. C'est combien de minutes de questions pour chaque personne?
Moi, ça dépend. C'est, D'habitude, tu as plus pour les reviewers 20 minutes, peut-être
Chacun? Ok.
une demi-heure.
Ok.
Depends.
Ok. Être gentil pour moi.
Je suis un examinateur, non spécialiste du sujet.
J'espère, hein.
Non, ne t'inquiète pas, j'ai que des questions gentilles.
Merci, merci, c'est super.
Except, how come you didn't evaluate on RAG?
Non, je ne travaille pas sur le hack, mais pour le perspective, pour le général,
Ouais,
vision générale, genre, j'aurais posé un peu de choses sur ça, mais je suis pas dans ce domaine-là, donc pas de questions super, super profondes.
non. Non. Oh, t'as eu des nouvelles de ton papier Sigir 2026?
Non, ce sera dans 2 semaines, quoi.
Ok.
Dans une semaine. CrossFit Pink.
Et après, tu fais quoi? Tu fais un postdoc?
Je sais pas, j'ai pas encore
Ton contrat, il finit quand?
le fin mars.
Ça. Ok.
Fin mars, ouais, donc c'est fini. Donc, mais j'ai des en chômage et je peux demander un chômage
Et
d'après
ton visa, il finit quand?
le fin de mai.
Fin mai? Ok.
Ouais. Mais je crois, d'après, si j'aurais une avis de situation de mon chômage, je peux demander une prolongation de mon visa.
Ouais. T'as pas cherché de postdoc? T'as pas eu le temps?
J'ai pas eu beaucoup de temps de bien trouver des postdocs, mais peut-être aujourd'hui je vais discuter un peu avec Sean et peut-être avec David parce que je voudrais de faire des choses sur le postmodal, retrieval, des choses comme ça. Bon, bon, disons, ouais. Attends, attends. Tiens, juste sur route. Ah, c'est bon, hein. Ouais, en fait, ce que je me recherche, c'est pour une position industrielle de recherche, mais d'après ce que j'ai fait pendant mon test, peut-être c'est pas très.
Tu as postulé chez Lighton?
Mais ouais, ouais, j'ai dit à Antoine, et puis
Ouais. Ils ont rien chez eux?
non, il m'a dit qu'il essayait, mais il n'y a pas de position, il ne recrute pas pour l'instant.
Ouais, mais parce que chez eux, t'aurais été bien, hein.
Ouais, 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 c'est super bien, ouais, là-dedans.
J'ai une thèse cifre avec eux sur le post-training et tout.
Ouais,
Ouais, ça se passe plutôt pas mal.
ok.
Mais t'as essayé aussi chez Mistral, tout ça, ou pas?
Mistral, je crois que c'est difficile pour moi pour une poste de recherche, mais pour le poste d'ingénieur, je n'ai pas essayé.
Ils recrutaient comme des malades en ce moment, donc
Je sais pas. On
ça.
discute ça pendant le podcast, hein.
Oui, oui.
Maintenant, je veux concentrer un peu sur le... Mais, ouais, ouais. Hier, chez moi, je veux parler super fluent, mais aujourd'hui, peut-être devant tout le monde, je sais pas si je suis un peu stressé. Et...
C'est une formalité. Donc,
Ouais, Sean m'a dit Sean m'a dit
you
la même
got the,
chose.
you got the papers, you got the good work, very good paper, very good advisor. It's a pure format.
Ouais.
Does,
Hi, Yash.
how about your family? Are they going to be online?
Yes, they are now. Hello. Family? Thanks for coming. Yeah, a little stress, but that's Dame, who will be how to say, the president of the
I
defense?
think 100% it might be me, but I'm not sure.
Okay. It depends my first question. If it depends my first sentence, I need to say thank you, Jamie, or thank you to other people.
I'm going for a smoke.
First. Yeah.
Déjà sorti.
Hmm?
Déjà sorti.
Non, j'ai pas vu. Ah ouais, allez. Ok. Dans ça, t'as trouvé. Admettre, c'est ça?
Ouais, ouais.
Admettre.
T'as eu tes deux ou t'en as qu'un?
Les deux sont tous arrivés.
Après, il faut que tu.
Tu peux m'entendre, Linda?
Bonjour. Oui, 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 j'entends très bien. Salut
Oui,
Philippe.
moi également, j'entends très bien. Je ne sais pas si vous m'entendez, mais j'entends.
Je vous entends,
Ok,
t'inquiète.
merci.
Ok, c'est bon.
Et tu peux mettre déplacer le.
Ah, il faut d'abord cliquer et puis je peux cliquer ça. Ouais, ça.
Oui, et mettre la vidéo
Ouais.
des gens aussi, juste.
Oh, je vais dire tous les
Tu peux
trucs.
la mettre là.
Là, comment je peux le faire? Je crois que c'est par là. Non.
Pardon.
Ah ouais, ça va. Ça va si...
Au début, tu la mets là,
Ouais.
quand le jury va arriver.
Ah,
Puis après, et après tu la mets où tu veux. D'accord?
Ok, ok. Est-ce que je peux me mettre ici?
Oui, après tu la mets.
Toi. Ok, ok.
Ok. Tu vas causer et après tu la remets. Bon, tu la remets dans le coin. Là. Tu la remets dans le coin en haut
Ok,
quand il y aura une question.
ok. Donc c'est vers la gauche, c'est ça?
Ouais.
Donc,
Voilà.
ah, ok.
Voilà.
Mettre d'abord là.
On fait tout ça. Ouais.
Je sais pas si j'en ai des figures là-bas. Je crois, je crois.
Non, mais après tu l'enlèves quand tu vas parler.
J'arrive. J'arrive.
The person is living on this campus and they got arrived. Philip and Linda arrived. But you need to speak louder. I think she should help. Philip is not here. He's not bad. Okay, Philip's here.
C'est les gars, quand même. Il y a une fois fait que si on donc, je sais pas. Ah, je pense que une façon non, je suis pas des R, mais des R, ceux qui partent. Je parlais. C'est passé. C'est passé. Ouais, ouais, on s'est là-dessus. Je savais pas faire un remplace pour moi, ça. Ça me fait je sais pas comment il. Parce que moi, je une fois, j'ai fait probablement, c'est probablement moi. Donc, je suis sur la partie tout seul, en fait, vous l'avez. Les personnes avaient soulevé le dossier soir. Ouais, mais. Comme j'ai demandé, j'ai eu c'est d'autres choses pour la charge de bref. Il y avait d'autres symptômes numériques parce que ça m'en parle. Je fais sûr. Parce que dans les règles, j'aurais pas dû demander. On a valide le 375. Philippe, tu nous entends?
I think you has muted. He has muted.
Oui, je vous entends. Je t'entends.
Moi aussi, bonjour tout le monde.
We wait here for about 30 minutes. 1 or 2 minutes, or we directly start.
It depends on the president of the.
When we start?
Oh, let me do the introduction first.
Do you think we need to wait some other people come or?
The jury's here. You are here.
You are here, the jury is here. Just needs to make the introductory announcement. And then Shall I get please? Thank you. So we're here today for the defense of Yuxuan Zong for his PhD thesis towards efficient and effective vocabulary in sparse information retrieval. The jury members are Professor Linda Tamim, who is remote from Toulouse, Philippe Mulheim from Grenoble, who is also remote, Jamel Seda from INRIA Paris, Miami, Sean McCartney from Glasgow here, and myself, Ed Picard from École des Ponts. The PhD was supervised by Benjamin Pivovarski. So you have 45 minutes to do your presentation, and then we have the discussion session. You can start whenever you're ready.
Okay. Okay. Hello, everyone. Thank you, David. Hello, everyone. Thank you for being here and attending my thesis defense entitled "Towards Efficient and Effective Vocabulary in Sparse Information Retrieval." Information retrieval is a task that focuses on efficiently retrieving the relevant information to satisfy the user's information need. It has several applications, including the web search engines, the recommendation system, and more recently, the retrieval augmented generation. In this thesis, we focus on a task called ad hoc retrieval, where we try to compute a relevant score for a query and a document. Based on such score, we can then rank the document according to this and get the most relevant one. The earlier approach of the information retrieval of the ad hoc retrieval focused on the lexical approach, for example, the famous BM25 method. It considers a document to be more relevant. It contains the lexical terms from the query. Given this example, given the query bank interest rate 2025, the upper document is considered to be more relevant than the later one, as it contains these lexical terms. However, it could suffer several limitations. The first is the vocabulary mismatch, where the text use different lexical terms to represent the same semantics. And also, we could have the semantic mismatch, where the different lexical terms, where the same lexical terms are used to express the totally different semantics. Early approach proposed to alleviate such problems based on expanding the query and documents lexical terms. And another approach proposed to represent the document and query in a vector space with a neural network. For example, the lexically related terms are more closer in the vector space. It gives a rise to early neural models, but however, they're still not that good because they cannot still handle the semantic mismatch problem. Okay, the newer era of information retrieval arrived with the pre-trained language models like the transformers. It can provide a contextualized representation for the input. Give an example for the text bank interest rate 2025. It would after encoding, it would give the contextualized representation of lexical bank close to the semantics of the financial and push it further from the semantics of the river. Based on such models, such representations, how can we build the models and to model the relevant score based on this kind of contextualized representations? There are in general 4 categories. On the right-hand side, the models are more efficient, and on the left-hand side, the models are more effective. Among those, there are the interaction models, which propose to represent the document and queries into multiple vectors. And what differs from the early interaction models and later interaction models are how the queries and tokens interact. On the right-hand side, we have the learn dense models and learn sparse models, where both models propose to represent the documents as single vectors and then apply a dot product on top of it. Such models are more efficient. Meanwhile, there's a 5th model category, which is called the generative models, which we will debrief that later. Okay, among those, the learn sparse models is the most interesting as it has a good balance between the effectiveness and efficiency. Regarding the problem of the traditional lexical methods, which have the vocabulary and the semantic mismatch, the learn sparse models like Splay performs the term expansion and term ratings through a kind of MLab ahead projection. On the right-hand side, give an example of before and after its kind of expansion. Given the text bank instruction rate, it increased the weight of the lexical term bank because they think that this term is more interesting or contains more semantic meanings. And it also expands the lexical term ratio to alleviate the problem of vocabulary mismatch. However, we argue that such kind of models still have some limitations and not perfect enough. First, to alleviate the vocabulary mismatch, such models usually tries to expand the representations with the lexical synonyms to represent one simple semantics. Given an example that's a bank interest rate, it tends to expand to distinguish the semantics of Bank of River to the Bank of Commerce. It expands the lexical synonyms like the financial commerce. It will largely increase the non-zero component of the lexical representation and could thus harm the efficiency. Second one is that due to such kind of vocabulary expansion, we could still encounter the problems of the semantic mismatch, whereas one lexical term is used to represent different semantics. In this example, the upper document and the lower document share totally different semantics, but they both activate the lexical token bank. The third one is that for the same context, for same semantics under different contexts, they would rather under different languages, they would rather activate lexical terms under different languages, which makes such models is not that good for the multi or cross-lingual adaptability. Furthermore, another thing we identify is that such kind of sparse representation cannot handle well structure between terms. For instance, here, the lexical term bank and the lexical term financial has a clear coarse-to-fine representation among them, but such kind of information is lost into this kind of sparse representation. Okay, let's go back to the generative retrieval, which is a method which we appear just before or at the beginning of my thesis. This different from the traditional methods, which requires to build an index and retrieve from it. It proposed to do a one-to-one mapping between the document identifiers and the corresponding document. And during the retrieval, the document identifier is generated conditional on the input query. For instance, this identifier is to be seen as a lexical terms derived from the metadata, or it could be the arbitrary identifiers derived from the hierarchical clustering based on the fits embeddings. We argue that such methods are not that good in generalization because it still relies on the one-to-one mapping. But we argue that this kind of structure is very interesting and we can leverage them to build better vocabulary and indexing them for the sparse models. It has several benefits. First, it can provide a better vocabulary, which is different from the traditional sparse models that relies on the MLA head and relies on such kind of predefined transformer vocabulary. And second one is that it can provide a coarse-to-fine representation. On a high level, the coarse representation could help the model to capture a broader concept, and at a lower level, it can help the model to capture the fine-grained information, which can help the model to do some exact information matching and to be more specific. And the third reason is that it can provide the model a larger vocabulary. For instance, if we go one more depth into this kind of tree structure, we can have an exponentially growth of the vocabulary size, which can be good for effectiveness and efficiency. Okay, so we propose our first research question of this thesis. How can we define a semantic vocabulary for text representation, and how can we structure them? First, inspired by the success of the generative retrieval methods, we propose a method which is called referential, that we generate a set of hierarchical identifiers for full text instead of the one-to-one mapping. However, we find that it fails to work as it is hard to generate diverse identifiers. We proposed the hotbed, which is inspired by the latent interaction models, which we try to generate one hierarchical identifier for every token representations, so that it will naturally cover different semantic aspects. However, we find that they are still very hard to generate this, so we try to relax the constraint to the unstructured identifiers. So we propose as displayed, where we generate a set of flat identifiers based on the concept instead of based on lexical terms that for every token representations. Okay, let's going back to the hotbed. In hotbed, we propose to generate one identifiers per document token representations inspired by the linked track models. And such models still has some problems. It requires to store every contextualized representations for the query document instruction, and it requires a huge indexing space. We argue that it is not necessary to store every document token representations, so we propose our second research question. How can we remove the non-essential token representation from multi-vector models in an effective and efficient way? Okay, so let's go through our first contribution, failure one, but very quickly. Different from the traditional generative retrieval models, which does a one-to-one mapping between the documents and document identifiers, our proposed method referential proposed to represent the text as a distribution over structured identifiers. More precisely, for the relevance between the arbitrary identifiers, we propose to use the common length of the prefix to reflect it. More precisely, given two arbitrary identifiers alpha and beta, which is associated with document, and one arbitrary identifier gamma, which is associated with a query, we argue that the document associated with alpha is more relevant to the query associated with gamma than the document associated with beta if alpha and beta share longer common prefix than beta and gamma. For example, here alpha and gamma share a common prefix of length 1, and gamma and beta and gamma doesn't share any common prefix. In this case, we can say that we have a pairwise relevance indicator, which is alpha is better than beta, then given gamma is 1. And based on this, we can then propose a pairwise training objective based on three random independent random variables, A, B, and gamma, which corresponding to the distribution of the identifiers for the positive document or the relevant document, for the negative document or the irrelevant document, and on the query. And this value could be seen as the estimation over this indicator function. In this work, we have tried various methods to make it work, but it fails. To train such models, we find that it requires a huge computational cost as we have too many queries or identifiers to sample in the space. But however, another important thing we find is that to generate such kind of identifiers, the identifier we generate usually lack of diversity. For instance, what we generate is usually like the distribution of D3, where it only concentrates on the main semantics. For example, the identifier 2, 1, but ignores the other semantics, for example, 1, 1 or 2, 2. Okay, due to this, we find that generating such identifiers based on a generative model is very difficult for the whole text. So we propose something simpler. Inspired by the latent interaction models, we propose that we can generate the arbitrary identifiers for every contextualized representations, as each of them naturally cover different semantic aspects. So we'll definitely have more more diversity. Okay, so let's switch to our second contribution, Hotbit. As generating the arbitrary identifiers based on a decoder model based on full text is difficult. So in this work, we propose to associate each contextualized representations to an arbitrary identifier, like this. Okay, and inspired by the success of the residual quantization, we propose that for each vector in the space, for each node of the arbitrary identifiers, it can be associated with a direction in space. For example, here. And more precisely, for each contextualized representations, it can be seen as a linear combination of the vectors. For example, here, and activation coefficient pi. For example, given the contextualized representation of the bank, it could be seen as a direction which is more coarse grain W1, which is related to the fine grain related semantic relatics, and then plus a more more fine-grained representation, which is called W11, which corresponds to semantics of the bank-related semantics plus the final residual. Then we could associate this arbitrary identifier 11 to this contextualized representation. Okay. In this work, as we associate one arbitrary identifiers for each contextualized representation, it will be hard to directly reuse the relevance function or the pairwise relevance scoring in referential, as we need to discover or explore too many branches. In this case, inspired by the Muvera, to reduce the number of token representations, we propose to associate identifiers with a cluster of token representations, and then apply the mean pooling on top of it. So it gives our scoring function of Hotbit. And further, based on our tree structure, we can design some fast retrieval algorithm. Let's assume that we have a query representation Q and a document token representation D, which share the same arbitrary identifiers. And thanks to the orthogonality along the path or along the tree structure arbitrary identifiers, you can see that their inner product could be seen as a scalar product between the activation coefficient plus the dot product between the final residual. And further, as we know the values of the activation values, we can predict the upper bound of the dot product of the final residual. And if it is smaller enough, we can then ignore it. And so it saves the computational cost. Okay. In this work, as we associate identifiers with a cluster of token representations, Ideally, the case which we want is that for the semantics with contextualized representations that share similar semantics, they would have the same arbitrary identifiers. Through such kind of things, we can make the semantics to be captured by different projection vectors. However, in contrast, there are two scenarios which we don't really want. The first one is that all the contextualized representations share the same arbitrary identifiers. It will make our model collapse back to the dense models, and we will encounter the same problems that we encountered in the referential, that it will only generate one arbitrary identifier, so it will be still lack of diversity. The second thing we don't really want to have is that each arbitrary identifiers share a totally distinct, each contextualized representations share a totally distinct arbitrary identifiers. It will make our model collapse back to the original Colbert model. However, it will make such model very effective, but it's not exactly what we want. More precisely, it will make all the token vectors put a big norm on the single direction, and all the projection vectors will be along this direction. It will make the generated identifiers totally random. However, the performance can still be kept. For the IR performance can still be kept due to the matching between this final small norm residual. It cannot make due to this, it cannot make this kind of semantics to be captured through this structure. Okay, during this work, we propose to train the models based on the Colbert, starting with a Colbert checkpoint and starting with a Colbert training objective. And we also add the regularization to reduce the norm of the vectors of the final residual. We encountered unluckily, we encountered a second failure, which we just described. We propose several solutions to targeting this. First, we try to reduce anisotropic of the space, as all the vectors are towards the same space, towards the same direction. For example, we leverage the Collier loss, which is designed to do this. And second solution which we propose is that we try to force all the identifiers to contain the semantics rather than relying on the final small norm residual. And to do this, we propose the IR objective that tries to reconstruct the IR objective without using this final residual. However, these two methods doesn't really work. So we think that generating the arbitrary identifiers is still too difficult. So we try to relax this kind of constraint and try to solve the vocabulary and semantic mismatch problems based on the concept-based vocabulary rather than the vocabulary based on lexical terms. Okay, so let's go through our third contributions as explained. Okay, as in the introduction, we say that the learned sparse retrieval models based on the lexical terms are still not that efficient and not that effective, and it could be bad on the multi or cross-lingual adaptivity task. So our question is that for the sparse models, can we go from using the lexical term representations to the concept-based representations? More precisely, for the first case, where instead of using 3 dimensions, we only use 1 dimension that exactly catching the semantics of the bank rather than using, and it can be more efficient. For the second case, instead of using the same lexical terms across different semantics, we use totally different concepts, which is the bank of commerce or the bank of the river across different to solve such the semantic mismatch problems. And for the third problem, if no matter what languages it will activate the same latent whatever the given input language. So it will have a better cross-lingual or multilingual adaptivity. And our solution is that we can try to leverage sparse autoencoder. There are also some previous work which already targeting at this. For example, the CLSR, which proposed to decoding the dense vectors with a sparse autoencoder and then leverage the BM25 line scoring them. There's another method which is called Splayer, which is more recent, and it proposed to use a predefined SAE from a large language model and then try to train them without adapting the sparse autoencoder for the model. And it is both different from our works. Okay, as we are going to discuss about use this kind of sparse autoencoder, I will first try to explain what it is. Sparse autoencoder are used to interpret the behaviors of large language models. The sparse autoencoder decomposes each tokens into multiple SE latent, while each of them capturing different semantic aspects. For example, here, for the contextualized token representation baked, it activates the semantics of the bread, of the cake, or of the cooking skills. And inversely, an SAE latent could be activated by multiple tokens across the text. For example, for the latent cake and baking, it can activate by all the highlighted tokens over here. And we also want to describe a little how the sparse encoder can be trained. It usually consists of three components. It consists of a SAE encoder, which tries to project the vectors into the hidden latent space, and then followed by an activation function that tries to ensure this kind of space is sparse. And then it is followed by a SAE decoder, which tries to reconstruct the input vector. Okay, to connect the sparse autoencoder with learn sparse models, for example, SPLADE, we propose two-step training strategies. First, in order to obtain a semantic vocabulary or the concept-based vocabulary, we propose to freeze the parameters of the pre-trained language models over here, and then train only with the sparse autoencoder's objective. And for the second step, after getting this kind of concept vocabulary, we propose to ignore the SAE decoder and then train it only with the SPLADE objective to obtain a learn sparse model that is good at effectiveness and efficiency. And for the activation function, we propose to use a top K SAE, which tries to mask all the latents to 0 whose activations are not among the top K. We didn't use the other jump rules because they are much harder to train. Okay, to validate our proposed methods, we propose several questions. The first one is that although several SAE designs have been proved to be useful for the LLM interpretation, their effectiveness for our proposed methods is really unknown. So we propose, and second, based on our best chosen design, how does our method compare to the other state-of-the-art methods on the retrieval performance? And third question is that in the introduction, we described that the learn sparse retrieval models based on lexical terms are not good for the multilingual settings. How does our SAE SPLADE models performs? To evaluate our models, we propose several evaluation matrix. For example, for the IR matrix, for the effectiveness, we use the traditional IR matrix like the mean reciprocal rank or the MDCG. And for the efficiency, we use the QD flops, which is the estimation of the posting entries during the retrieval, which is widely used to evaluate sparse models. And in this work, as we propose several SAE SPLADE variants that covers different effectiveness and efficiency trade-off, we need a matrix that we can help to combine them. We propose to leverage this value, this E square, over here, in all these later experiments, we report the delta E square, which is this value minus the value of the BM25. If the value is lower than 0, it means that it is too bad. On the right-hand side, give an example. The x-axis is the QD flops, which reflect the efficiency, and on the y-axis, it is the mean reciprocal rank, which reflects the effectiveness. We have three models which locate here. The red and the purple one are on the same curves, so we argue that they share the balanced effectiveness and efficiency trade-off. We argue that we can trade for 1 point on the mean reciprocal rank 10 and to gain 1 point effectiveness on the QD flops. For the blue point, which is worse, as it is lower on this kind of curves. Okay, for the traditional learn sparse retrieval models, which is based on lexical terms, they have to rely on the MLM head. But in our case, we can decide which layers of the base models we can use. So we design this kind of experiment. We varies the different layers of the traditional distilled blood models based on layer 6 to 3. And we show the experimental result on both the effectiveness set, the efficiency set, and our combined matrix. We find that using the layer 6 gives the last hidden state gives the best performance. It can achieve the good effectiveness, and it can achieve a better QD flops. Why the sparsity is a little bit worse? We argue that this kind of representation could better leverage the hidden space, so it can provide a better representation ability. For example, to validate this, we try to calculate the anisotropic before and after the training, and we find that it is indeed the case. Okay, for the second one, we try to, as several SAE variants have been proved to be very useful for the LLM interpretation. For example, the hierarchical top KSAE and the Matryoshka top KSAE, which propose a kind of coarse to fine representation in the SAE latents. But their effectiveness on our proposed SAE split method is unknown. Furthermore, for the different values of the K for the top KSAE, they could have different effectiveness and efficiency trade-off. So which K values is most suitable for us is still a question. So in this case, we propose to evaluate both of these aspects. On the left-hand side, we show the experimental result. The x-axis is QD flops, and the y-axis is the mean reservoir rank. We show besides the models in cross, which is the top KSAE, we also illustrate the result in triangle for the hierarchical top KSAE and in cross for the matryoshka top KSAE. For different value of Ks, we represent in different colors. Regarding the values of K, we found that using K equal to 4, 8, and 16 achieves the best effectiveness and efficiency given on our design matrix. And if we go beyond K equals to 16, we don't observe too much performance gain, but we observe a very huge degradation on the performance, on the efficiency. And regarding the perspective of the SAE variance, we found that using the top K SAE can still performs much better, generally better than the others, and using the others don't provide no clear advantage. It shows that although this variance to be useful for the LM interpretation, their effectiveness for our top KSE remains very unclear, and it is not unclear, but there's no advantage. Okay, based on our best design, so we propose to evaluate our models with the other state-of-the-art methods. For example, the BM25, the CLSR, the SPLADE, and for dense models, we choose the SIM-LM, which is the dense models which to decode for the CLSR. And we also propose the latent interaction to compare our models with the latent interaction models like Colbert, which is the most effective one. Okay, compared with SPLADE, our methods achieve a very similar effectiveness, but our models have a much better effectiveness on the QD flops. Compare with our most efficient model, compared with CLSR, our models have a better effectiveness and better efficiency. And compared to the state-of-the-art method, Colbert V2, our models has just a very slight drop on the effectiveness, but compare latent interaction models with the sparse models, the sparse models are definitely better on the effectiveness and on the retrieval latency. Okay, for our third question, which is the multilingual experiments, to evaluate whether our proposed SE SPLADE is better on the multilingual task, we try to do this. On the upper side of the figure, we show the baselines, and on the lower part, we show our reproduced SPLADE and the SE SPLADE based on training on the MMARCO dataset and evaluate on the Miracle dataset. We found that our models achieve a better performance than SPLADE and slightly on the effectiveness side and largely on the efficiency side. We're showing the benefits. And on the other side, we still have a huge distance from the state-of-the-art method. For example, the Miracle, which leveraging a better and larger vocabulary, and it has a better vocabulary alignment strategies. So it still shows that there's still room for improvement. Before concluding, we have another question is that if such kind of performance gain is really due to we have a better SAE pre-training, or the SAE pre-training is really useful, or due to some other confounding component, for example, top K sparsification due to the top K SAE. So to evaluate first, we try to compare our method with the random head, which doesn't require any SAE pre-training. And to compare a second question, we also apply the top K sparsification for the SPLADE models. And we show the experiments on the later side, on the lower part. For the first sub-problems, we found that indeed our SAE model is much better than the random head, which doesn't require any SAE pre-training on both of the effectiveness and efficiency, which shows that our models have a better effect. Indeed, the SAE pre-training is very important. And for the second one, compare the SAE with the ML head, we found that our model is a little bit better in the in-domain evaluation, but slightly worse on the out-of-domain. It is expected because we argue that the models based on the context vocabulary is much better because it can catch better the semantics relationship between the seen query and documents. But on the out-of-domain, the lexical matching plays a more important role both regarding the unseen entities. And finally, we found that indeed the top K masking is beneficial for all vocabulary types, especially for the random vocabulary. We find that it has a huge drop of the QD flops, while the performance gap between on the in-domain evaluation and the out-of-domain evaluation is very limited. Okay, before conclude, we just did some qualitative analysis on the vocabulary mismatch and semantic mismatch scenario. Regarding the vocabulary mismatch, we select several synonyms that cover the similar semantics. For example, the dish, the soup, and paper, something like this. And we find that they activate often the same latent identifiers. And for the semantic mismatch problems, we choose different lexical tokens like the spring and bank, which would cover different semantics under different contexts. And they will activate different latent identifiers. Okay, so in conclusion of this section, we propose SE display, which leverage a concept vocabulary for the learned sparse models. And we conduct huge qualitative and quantitative experiments to show and analysis and to show the benefits. Additionally, we find that the top kick masking, which is a constraint, it is quite beneficial for our SE display models and also beneficial for the original display models. In this work, as we discussed, we still have some limitations. For example, as we see that the SE display is quite beneficial. It still has some distance with the state-of-the-art method like Medical. So our future work maybe is to propose some better foundation models and better training strategies. For example, the lexical alignment. Okay, so let's switch to our fourth part, the multi-vector token pruning. Okay, let's going back to the hotbed, which we associate one arbitrary identifiers with each contextualized representations. As we have such much arbitrary identifiers, it will make such models very hard to train. And meanwhile, it is based on late interaction models, which requires to store every contextualized representations. Thus, it requires a huge index space. So for both methods, the token pruning is a very important task. As unluckily, the hotbed doesn't work. So in this section, we leverage the hotbed models, where the scoring function is a dot product, the maximum dot product for the query and documents, and then accumulate all the queries. For the relative work, there are several directions. First, the most easy one is try to do the vector compression, for example, leveraging the quantization. And second one is that based on clustering, which tries to remove the documents based on the clustering and assign each document tokens with the cluster it belongs to. And the third direction is based on pruning, that is to say, we just keep a subset of the document tokens. There are two subdirections of this one. The first is based on statistic or heuristic approach. For example, such methods propose to reduce the stop words, remove the tokens with low IDF values, or remaining tokens based on the first K tokens. Such models usually degrade a lot of the performance if we keep a high pruning ratio. And another approach is based on the dynamic approach. Several methods propose to leverage the gating mechanism, for example, to learn which kind of tokens we need to remain. And the new approach arrived last year is constant BERT, which tries to project the original project the vectors token vectors into a subspace and only remaining this subset of vectors. This method usually performs better than a statistical one, but the impact of these removing tokens on the final score is still unknown. So in this work, we propose that if there's some way that we can remove the document tokens that have no influence on the final scores. Okay, so let's reformulate this better. Our idea is to say, can we remove the document tokens that will never match any query tokens? Given the original corpus score like this, our idea is to say we want to find a subset, which is called D plus here, that for any query tokens, it will only match the document tokens in the subset D plus instead of the original set D. And based on this, we can then rename the corpus scoring function only with the set D plus, so it can save the save the index size, and meanwhile this reduction is lossless. However, based on the original corpus settings, it is very hard to obtain. On the left-hand side, we give the current formulas. On the right-hand side, we give an example, where D1 to D5 are the contextualized representation of a document, document contextualized token representations under one document, and the sphere represents a query space. For a document, for a query that locates sorry. For the queries that locates in the corresponding area, it will have a maximum inner product with the corresponding document token representations. Given the original corpus scoring function where every document tokens are normalized, they will have a we can see that although these 5 document token representations are close, they will still match some of the query token representations, unless the 2 document token representations are exactly the same. So to alleviate this, we propose that we can reduce the num of the vectors to be smaller or equal to 1. Based on this, you can see that from the perspective of document token representation D5, it will have no query tokens will match it. So which means that we can remove it without any loss. But can we still do it better? So let's take the example of the document token vector D3. It will match the queries which locates in the gray area, but it is only because it has a higher negative inner product with it. We argue that this kind of negative inner product matching is not important, as the Hilbert space is very anisotropic. So to solve this, we propose to add a ReLU on top of this. Currently, an area is colored only if it has a maximum positive inner product with a corresponding document token representation. From a perspective of document token D3, it will for any query tokens, it would rather have a negative inner product with it. For example, the hatched area, or it would rather match the document D4, D1, and D2 instead of D3, which means that we can remove the document token D3 without any loss. Compared with the other previous method, which is based on the gating mechanism, for example, based on the norm, it will remove the document token vector D2. And when the query locates in the green area, it will introduce some loss. Okay, so in the previous slide, we have to do something. So currently, we can propose some definitions. We define that for a document token vector D- is locally dominated by a set of document token representation D, that for any queries, they would rather have a negative inner product, which is the hatched area in the previous slide, or it would have it would match the other document tokens instead of D-. For example, the D1, D2, and D4 in the previous slide. Okay, so we can compute this, we can evaluate this kind of definition individually for each contextualized representation of a set of documents. And if it's true, we put in the set D-. And we know that the set of D- is dominated by the original set D. But however, what we want to know is that if the complementary set D+ is D- is dominated by its complementary set D+, because the D+ is the final set we want to remain. And we find that it is indeed the case. Okay. Through this work, we find that the dominance is actually equivalent to a linear programming problem. But it is very hard to achieve because this linear programming method requires the vectors to be in the span of the others. So we propose to approximate it. We propose to truncate the document token representation vectors by a singular value decomposition and then apply the linear programming on top of it. However, we found that the linear programming compared to the other method is still very time consuming. So we propose some heuristic-based approach. For instance, we can as we see that the tokens with small norms or with the zero norms is definitely to be dominated. So pruning based on the norm of factors is also intuitionally correct. Okay, so in this work, as the original Hilbert scoring function is not designed to prune tokens directly, so we propose several regularizations. In this work, we propose the nuclear norm, the document token similarities, and the error one norms. All these methods, I will not go into details, but all these methods only have one goal, is to make more tokens to be dominated. Okay, so in this work, we propose to evaluate our methods on the in-domain and out-of-domain dataset, and try to do a track point selection based on the weighted harmonic mean, which has a balance between the effectiveness, which is IR performance, and the efficiency, which is the pruning ratio. For the baselines, we compare with the state-of-the-art baselines like Splade and Hilbert, and for the pruning baselines, we compare with the one which we mentioned in the previous related works. In this figure, which on the right-hand side, we show the in-domain evaluation results for the baselines without or with pruning. And then on the right-hand side, we show our models based on different pruning threshold and different training recommendations. In this work, we find that our best performance models have a comparable performance with state-of-the-art Hilbert baselines, while only keeping 50% of the original tokens. And meanwhile, compared to the other pruning baselines, our models achieve a better performance on both the pruning ratio and the information retrieval effectiveness. We also evaluate our models on the out-of-domain task, And we find that our models is not as good as Colbert in the out-of-domain task, but it is still better than the other pruning strategies. Okay, we also illustrate a qualitative analysis. We randomly sample one document from the MS Marcos, and we show and we prune it and train it with different regularizations and different pruning strategies, and the remaining tokens are in bold. We find that generally the remaining tokens are generally the nouns and verbs. It matches with the human intuition that this kind of lexical terms contains the most of the semantics. However, compared with the different pruning strategies, we find that for the LP-based pruning, the third appearance of the lexical token population has been removed, and the non-pruning doesn't do it. It shows that our LP-based pruning can prune more remote tokens on the duplicate tokens, as its semantics are already covered by the previous appearance. And similar things happens to the second appearance of the city. Okay, in conclusion, in the next section, we propose the definition and the framework of the dominance, and we try to adapt the Colbert scoring function. And more precisely, we also propose some approximate pruning method and regularizations to make this true in practice. Finally, we conduct several qualitative and quantitative experiments to validate our methodology. Our methods still have some limitations. First, as we previously mentioned, the linear programming still has a very huge computational cost. And second one is that our proposed regularizations are still not that perfect because our regularization is still a little bit based on the heuristics. And as the linear programming is not an easily differentiable task. So there's still some distance between the training and the pruning strategy. Okay, so let's go to the final conclusion, the future work, and the perspective of this thesis. Regarding the first research question, we first propose to leverage the structured representation for information retrieval, and we propose the referential and Hobbit. We find that indeed such kind of structured representation indeed has some potentials, but they are really hard to optimize, and unlikely will fail to work. And for the future work, due to the success of the essays played, we found that training such vocabulary based on the reconstruction is a good idea. So to inject the semantics into the tree structure rather than rely on the final residual, we can propose to use such kind of reconstruction laws to force it. And second contribution is a flat representation for information retrieval. We propose the SAE split, which leverage a concept-based vocabulary rather than the lexical-based vocabularies. And we find that indeed, a better vocabulary representations can improve the retrieval performance. For the future work, we identify two. The first one is that currently, as we are still using a two-step training, it is not that end-to-end. It can make the model very hard to apply directly in the for engineering. So we propose that we can design some better ICE architectures or training objectives to match this kind of information retrieval objective. And second one is that as we argue that lexical tokens has a good performance on the out-of-domain and SAE has a good performance on the in-domain, why cannot we combine these two? And this is the idea which we inspire from the recent work MIDCO, which tries to use the in-domain for the multilingual, the lexical terms for the multilingual, and use the different languages for the out-of-domain. Okay, and for the second research question, we propose the token pruning for the interaction models. More precisely, we propose a method to remove the tokens that are not useful for late interactions, and which leads to lossless token pruning strategies. Concerning the limitations we have identified, we propose to leverage the Monte Carlo method, where we randomly sample the query tokens and then try to prune document tokens based on the empirical matching frequency of the document tokens. For the future work and perspective, as currently the late interaction models or all the interaction models, they have a good good effectiveness, but their efficiency is always a big problem. So how to prune them is a very important question. We identify two things. The first one is that for such kind of pruning, we cannot only limit it to the late interaction pruning, but we can also apply such to the early interaction, which is, for example, the re-ranking. Based on this, we can then remove some of tokens and we will reduce the context size for the transformers. And second one is that for the pruning, it is not only limited to token pruning, but we can also apply such kind of pruning over the interactions. following previous work like Preacher. I don't know if I pronounce it well. The stack pruning, so we can apply some kind of mask on top of it, so it can reduce the computational cost. And for the general perspective or the general vision, we propose two. The first one is that as generative models are quite hard, we can leverage them for the information retrieval task. The first thing is that we propose that the most hot one is generative retrieval, but as what we described, it is very hard to generalize. So in our work, we propose to generate the query specifications instead of the query identifiers. And then we can leverage this kind of query specification to be treated by the retrievers. So it is a little bit like the idea of the query writing. So in this work, we propose a cluster which we try to optimize the small language models with a GRPO, which based on the relevance feedback. And then we find our models have a better performance than the generative models, but we still have some distance with the state-of-the-art method like the split or covert. And the last page is that currently the information retrieval is also very important for the generative task. If you consider an LLM which doesn't have access to the real-time information or have real-time internet access, it can be just seen as a mobile phone which is on the airplane mode, and it can hallucinate quite a lot. So there are current two directions which are quite interesting. The first one is that we can propose for the RAG systems or for the AI agent, the context compression is a very hot topic. But we argue that our late interaction model pruning can be a very important because it can also be leveraged for such kind of context pruning. And our method, one good point of our method is that we know that which tokens can be remaining. So it is more interpretable for the community to know that which kind of information is useful for the LLM generation to give the good response. The second one is that on the internet, currently, there are more sources of the information rather than purely relying on text. For example, there are, besides of the text, the access of the audio, of the speech, of the figure, they are always interesting. And there are the information of different languages. So we believe that this kind of information access is important for the LLM to give a good answer. And we argue that our proposed method as displayed could be also applied to such scenarios to apply for the multimodal retrieval. More specifically, specifically, we can use only one SE latent for the concept based on different modalities. For example, one dimension for the describing the semantics, the audio that describing the bank, one same dimension that describing the figures that showing the bank, etc., etc. And we believe that our method can boost the effectiveness and efficiency for the multimodal or cross-modal retrievers. And here is a list of the publications and the conference that participate during this thesis. And that's all. Thank you.
Thank you very much. So we'll now continue with the discussion, starting with the people who reviewed your manuscript, starting from the furthest away, as the tradition goes. Professor Linda Tamil from IRIT.
I'll put this one out here.
Yes.
Thank you. Do you hear me?
Yes.
Okay. So thank you for this clear and informative presentation. The key contributions were clearly outlined, as well as the main findings and the key takeaways. The presentation was very nice. I really enjoyed it. I also enjoyed reading your manuscript. Although there were some overlaps, repetitions between the chapters I mentioned in my report, this was a minor point compared to the vast body of literature you have summarized by highlighting the critical aspects of the state-of-the-art work, putting the clear relationship with your proposal, with the well-positioning, as well as the relevant research question you addressed, and the relevance of your proposals. So congratulations for all the great work you carried out during your PhD
I
thesis.
already make you loud.
So,
Sorry, Linda, we just need to make this sound a little bit larger for all the audience could hear because it is only here by me. It is only here.
okay, so I should repeat from the beginning?
Vas-y, parle un peu pour voir.
Oui, là, vous m'entendez?
C'est mieux, ouais.
Ok. Ok.
C'est bon, le jury m'entend?
Ouais, très bien.
Oui, c'est mieux, merci.
D'accord, bon, je répète alors. Well,
Oh,
I was very happy with this presentation, so thank you for this clear and informative presentation. I say that the key contributions were clearly outlined as well as the main findings and the key takeaways, since you did a lot of work highlighting the failures and the success and the failure stories. I also enjoyed reading your manuscript. I say that although there were a few repetition overlaps between the chapter, as I mentioned in my report, this is a minor point regarding compared to the vast body of literature you have summarized, as well as the relevant research question you addressed and the relevant source of your proposals. So congratulations for all the great work you carried out during your PhD thesis.
thank you.
So that said, I would like to address certain aspects, either to seek for clarification for most of the cases, or
Okay.
to hear your views and comments. So do not worry, I will try to make it short today because my report was too long and too verbose.
No worries, no
Okay?
worries.
So my first question are about hotbirds, the first contribution you presented. Hotbirds, which generates one hierarchical identifier per token representation compared to the referencer, which instead operates at the document level and considers the document as a distribution of identifier. I really like this idea. It was original and I was quite, it was a pity that it doesn't lead to salient results and effective results. But the idea was very nice. I'm asking for clarifications. Did you see clear differences in the semantic spaces you obtained with the two models? For instance, is the cluster of token representation aligned to the document cluster associated to the distribution? It lacks some of the meanings of interpretability in your presentation. I mean, what were the gains and losses in terms of efficiency and effectiveness, and what were the key underlying reasons? Did you obtain the same semantic spaces? Did you explore more about what is the nature of the embedding spaces you obtained?
Sorry,
In terms of semantics.
sorry, just a clarification. What's your point? You are representing the referential or for the second contribution? The
I think my question is about the comparison of the two. Did you explore some comparison between the semantic spaces you obtained using the two approaches?
Okay. Actually, for the referential, what we obtain is that our generated identifiers are always like the D3 here, where all, for example, if we consider each arbitrary identifiers as a semantic aspect, what we generate is that identifiers mainly focusing on the main aspect rather than distributing the weight to the other semantic aspect. For example, given a document which describing the sport of France. And so our ideally that the main aspect is the 2-1, which corresponding to the semantics of the sports. And it should also assign some weight for the semantics, for example, 1-1, which is totally different, that describing the semantics of the France. But in our case, it's always focusing on the main aspect and keep no case for the 1-1 for the France. So it is not that satisfying for us. And for the hotbirds, the main question is that what we generated identifiers is a little bit look like this figure on the top side, which means that our idea is to make the different, for example, the D1 on the left-hand side, the D1 and D2 corresponding to the semantics of one semantic aspect, and D3 and D4 corresponding to identifiers of different semantic aspects. But what we got is that all the vectors are towards the
Okay.
same direction, and all the projection vectors are also into that direction. So it means that the choice of the arbitrary identifiers which we generate are totally random. So the identifiers are totally random, so it is not directly comparable.
Okay, but it's mostly related to the diversity of the identifier you obtained? What is the
Yes.
key reasons?
What do you mean by the key reasons? Okay, so you
Yes. What did you see this phenomena? It is related to the lack of diversity of the identifiers, maybe?
for the first case, we argue that it is because of the lack of diversity. But for the second one, as we try to make them each token contextualized representation generate one arbitrary identifiers, it should naturally
Okay.
cover different semantic aspects. And if all covers what we want is the case here on the left-hand side, where for the semantics close related lexical tokens or contextualized representations, they should cover one semantic aspect. And for example, for the France, they should cover the identifier 1.1. For all things related to sports, they should cover identifier 2.1. But in our case, what we got is that the identifier we generate are totally random. So we don't think it is kind of the problem of the design, but it's kind of the problem of that we cannot find a good way to train such models to get a good representation.
Okay. Thank you. Another question is about sparse autoencoder using SPLAT. Do you think that your approach is more generic and could be deployed to other sparse models of the same family than SPLAT? For example, DeepCT, Spartan, HDCT. What did you focus only on SPLAT? Is there any reason for that?
The most important reason is that the split is the state of the art. So reproducing them
Okay.
is
But
that's the most that's the
I
most.
think that the model could be deployed with other sparse models
I
of the
think
same family. Why didn't you explore that?
Because just the display is state of the art, and it is the most relevant one that has a clear advantage. It is clearly depending on basing on the MLM projection. So and for the DeepCT or the other models, I don't really remember, but I think they are also based on such kind of ML head projection.
Yes,
So
yes.
if they are also based on ML head, we believe that it can be also applied to such kind of vocabulary expansion and vocabulary to such models. I believe it also can be true.
Okay, but it still makes sense to make a mapping between the concept of the autoencoder and the lexical tokens from the other model. I guess that the deployment is possible is reasonable to set up and to design. I think this would enhance the extendability of your work to other models. That's what it was. It was a comment.
Thank you.
Okay, another thing that I didn't understand really the relationship between token concept mapping and the limitation you invoke about multilingual models. In
Okay,
their instance, concepts are core. Yeah, you
okay.
invoke the multilingual representation because
So
in my point of view, in their instance, concepts are core representative of human language and understanding. So do you mean that the model doesn't output the same concept with parallel corpora, maybe between two languages, or the limitations are related to the retrieval stage rather than the representation stage? I didn't understand this.
For instance, our case is that, for example, for a document which is describing the bank, the river bank, and the commercial bank, they should have, if they are not really related, their relevance score should be totally zero. But if in both cases, on the representation side, they both activate the lexical terms bank, they will have some similarities. And after doing this kind of product, their relevance score will be not zero. So that's what we say that this kind of semantic matching is not effective. And according to the multilingual, our idea is that for the representation under different languages, as they try to activate the same lexical, the different lexical tokens for different languages. For example, if a text that's saying bank in English, it will activate the lexical term bank in English. And if a French phrase that's saying bank, and it will activate that token bank instead of the English token bank. So this kind of matching will make such two models. We consider that these two kind of models are not relevant in this case. So it is not something we want. It is more related to cross-lingual instead of multilingual. Yes, I agree.
Okay, okay, but you didn't do the carried out any experiments on parallel corpora, no? Just to
Parallel corpora?
I mean the same corpora with different languages to confirm or infirm your hypothesis.
Yes,
The guess.
currently, yes, in our experiments, we only do it for the multilingual task, but for the cross-lingual task, it is a totally different task, so we didn't do this.
Okay. Regarding the contribution about token pruning, which was very nice, I have two questions. First, you relied on word dominance based on the degree of query document matching score. I wonder if you analyzed the preserved index, meaning the remaining index that you used, or tokens in terms of semantic and variation. Are the preserved tokens aligned with concept-based representation, for example, using a sparse autoencoder, for example? Are they query dependent? I guess it is the case. Are they document length dependent? Did you explore did you do some analysis about the preserved index? What's the shape of this preserved index?
Okay, actually, in
Because
our
when you
proposal,
do the pruning here, it's based on a leader relevance score. I guess there's some semantics behind that. We guess, okay. But really, what remains in the index?
actually, I just want to correct one point is that our method is just based on diagnostic. So our pruning is not based on the given queries. So our point is that for our pruning is that for every queries, for every possible queries, we need to prune them. So give an example here. Let's take the D5 here. So that our key is that the compared to the previous slide, we can see that the green the yellow area disappears, which means that for every possible queries in this two-dimensional space, it will not match the document token D5. So which means that D5 can be removed under any circumstances. So so I don't get what do you mean here?
My question is about the remaining index, all the token you preserve finally,
Yes.
the documents. Did you explore finally if do they represent some core semantics behind the document, some critical passages, in terms of semantic?
You mean the final qualitative analysis? Okay,
Yes.
I was sorry. Let's need to want to show. Okay, so for the semantics of the documents, what we remaining is that we propose this kind of remaining analysis, and what it remains is contextualized important tokens, and what's your question again? Sorry.
Okay, but there's just a qualitative example on some examples, no?
Yes.
You didn't do any projection on any space embeddings or to see some correlations between the embeddings? No.
For the correlation, no, but our analysis is just to see what are tokens to validate our design if we are putting the right documents or to the right contextualized representations, and the remaining one are indeed contains the important remaining one are indeed composed of the important semantics rather than remaining the token like word, remaining tokens like is, something like this.
Okay, and what we show here is that mostly related to the regularization, no?
Yes.
Okay.
It is trained by the
Here
regularization.
it just show the impact of the regularization. Okay, but regardless of the regularization you use, we don't see any salient behavior or sign remaining, what remains in documents.
Yeah, and actually, if you compare the vertically of the trees, for example, based on the same pruning strategies with different regularizations, another one important thing is that for the L1 non-regularization, it doesn't fit very well for the LP-based pruning, as it remains a lot of tokens than the other cases. So which means that the LP pruning has a much more distance with L1 regularizations. So it matches what we conclude at the final stage that the proposed regularization are not that perfect because there's still some gap between the pruning and the training. But for the LP pruning and the document similarity representation, the difference is smaller.
Okay. My second question is about there were a number of visual late interaction models that have been recently released, such as Colquen, for example. Do you think that the domains concept you build up in one modality and without a special focus on semantics will be able to tackle both compression and concept alignment between modality, for example, in cross-modal tasks?
Yeah, that is something which I describe in the final perspective, that I argue that this kind of pruning can be applied to also to such cases as, for example, for different modalities, we just need to encode them with different encoders. And for example, the audio encoders or the image encoders. And then this kind, as they are always they will still be represented in the same vector space for the interaction, for the query document interaction. So I believe that it will be the same. And I think this kind of application, our methods could be also applied to such kind of models.
Okay, and could you expand a bit more your thought about the expansion of your pruning model to RAG setting? One major issue I see, for example, is that there is an additional constraint that compression should preserve, for example, the generation between without compression and with compression.
I
Could
think
you envision your model and the extendability of your pruning technique to such to RAG settings? What are the additional issue you should tackle? What makes your contribution easily extendable to these settings, for example?
Okay. I mean that for the late interaction models pruning, our goal is to find the document tokens that will not match with any document tokens that will not match with any query tokens in the space. So if we extend to the context pruning, is that the document tokens that will never match any self-attention matching with the generation during the generation procedure. So that is also have a smaller inner product during the self-attention attention metric generation, and then after the soft max, it will have a limited score, so it will not contribute. So our goal is to going from this kind of direction to see if can prune without any loss. And so the compression is based on the lexical terms that will not match the data generation stage. So it is kind of pruning for the compression.
Okay. Thank you very much. It's all for me. Thank you.
Thank you. So normally we should go to the second reviewer, but because the second reviewer is acting as president today, we keep my question for the very end. And so we'll move now to Philippe Milhem from Grenoble. Philippe, second person that is remote. Who's remote? I don't know if you can hear us. And
yes, I put my mic on.
Yes.
Okay. You ready? Okay, let's go. So, thank you for your talk. As Linda already said, in fact, your talk was clear about your let's say proposals and the aspects related to all what you did regarding the generation of, I mean, okay, regarding all what you did, mainly what you did, I mean, I read your report, of course, and in your talk, we see that your work is very solid. You did many experiments for any of your proposals, in fact. And a thing which I feel is also very interesting to get from research work is that you are, I mean, you did not hide the failures, which means that research is based on successes sometimes. But most of the time there is a hard job which is done to make things work. And I think that it's very interesting that to explain all of these things that you did, because you did a lot of work, which is very impressive to my point of view. And still you also present things that do not work as you expected. And I feel that it's very, very, very interesting. This being said, so I'll ask few questions regarding your work. First thing is, I mean, I try to go linearly related your work, and exactly going back to your slide. I don't know if it's the 14th or whatever, but I mean things related to referential, and also in your report, you in fact, for referential and Hotbird, you say and you mention the fact that you do not, let's say, succeed, but I did still not see any reporting on retrieval experiments. Did you?
Yes.
I mean, maybe I did not read precisely in fact, but I think that I did not see it. So. Is there a reason for why you did not put a table or thing like this relating to a kind of quantification of the results, for instance, on
The
MS
results.
Mark?
Actually,
Yeah.
we did some final experiments based on our proposed training pipelines, for example, from the data generation and then by the fine tuning and then evaluating. But generally, we don't present because it's too bad. And I
That's
remember
life.
because
Too bad it's okay. Okay, which was very bad. I mean, we know we did experiments on things like this. I mean, in the past or whatever, we had only 0.0 something, and we say, okay, is this a bug or is it really running bad? But okay, so you do not want to tell anything about this.
actually, because what I was saying is that because for our experiments, we start with the MS Marco dataset,
Yep.
and for the MS Marco dataset, we are starting with something like re-ranking because we didn't use some very fancy inference matrix, so we are using some re-ranking, for example, based on say training objectives. So we just give two documents and give a query, we try to re-rank them.
Yep.
And our score is worse than BMD5 or loss, I think. So, and that is why we don't present them here. And one reason we don't continue into this direction is that we find that similar to the traditional generative retrieval models, generative retrieval models, I think I remember clearly that they fails to work on very large data set like MS Marco. So we propose to switch back to some smaller data set like the NQ 3200K. And on such data set, I don't know, our method still doesn't work as well as a generative model. So we began to believe that it is very hard. And maybe it is also because we have too many hidden space as what we say here. So example, we are not using a tree of length 2, width of 2, and length of 2. We're using, for example, a tree of length of 10 or width of 10. So it will give a potential of 10 million or 10 billion representations. So our training is just to sample one arbitrary identifiers and to see if it matches and if match the query. So in such huge space, we require huge computational cost. So that's why we don't want to continue in these directions. Okay. Although we believe that maybe if you use a smaller data set, it could work. But even on NQ330K, we doesn't find it works, so we don't think we have the need to continue on this direction.
Okay. I get it. Still okay, but okay. I get your point. You do not want to give numbers, so that's your right. Okay, so thank you. Now I jump, let's say, to essays played. We lose. I mean, okay. Let's say this: is there a way to, or mean or whatever, in your approach to keep a kind of explainability of the latent dimensions? Because, in fact, you use the latent vectors, okay, and I mean, compared to plate, for instance, okay, how can we keep explainability aspects in using your projection, in fact, in your space sports? They say, you get my point, or?
Yeah. For this one, let's explain with this one. So interpretability is just like a little bit that for the similar synonyms, they activate the same latent identifier. So we know that, for example, for the latent 6470, it corresponding to the concept of quizzing. So it is a kind of interpretability. And for example, for the later case, we can still see some kind of interpretatives. And another point is that SE is designed to interpret the LLM into behavior. So we can already say that it is kind of interpretation task. But the focus of my thesis is not to interpretable, but it is focused on have a better representation that can help the model to have better performance. And the interpretability is just a sub part of the goal. But here we can still find that there's indeed some kind of interpretability, so it can distinguish the semantics of the spring from the Clinton and the spring. I don't know how to say that, but and for the bank, it is different from the commercial and the outer banks, which is a river, I guess. Yeah, hurricanes, so it is a river. So it is kind of interpretability. But yes, I agree that compared with the traditional split, which is totally based on the lexical terms, this kind of interpretability is not that explicit. But we argue that, for example, let's go back to the case of the bank, it is interpretable because we can see that for the documents that relate to the bank, we are activated bank. But it is not that direct because for the terms that related to bank, the bank it activates is really related to the river bank or to the commercial bank. It is not exactly. For example, given a long document which contains the semantics of both the river bank and the commercial bank, and assume that we have a document that contains this, it will definitely activate lexicon of term bank. But among all the weights it contains, how much it belongs to the banks related to the river and how much it is related to the bank of the commercial, it is unknown. And it has to rely on the other expanding lexical synonyms like the financial, like the commerce, or like the river, or like the other terms. So this kind of interpretation it has some kind of interpretations, but this kind of interpretation is not exactly the interpretation we want.
Yeah. Okay. I get it too. I mean, okay, I agree. Thank you. I'm jumping. Let's go to your Colbert pruning tokens things, please. I think that's very, very interesting. The thing related to dominance, of tokens. It's very. I mean, for me, it looks smart, but you are smart. And okay? So you worked on this on Colbert, right? What I was wondering, trying to get a bit outside to what you did, and do you believe that there should be some way to? I'm not sure though, but I'm asking because you are smart. Shouldn't it be a way to, let's say, take the same inspiration that you did from pruning for Colbert, to let's say to use this kind of thing also, using some kind of representation of documents, for instance, that could compute, the sum of the embeddings of the term, for instance, for the document of the query and things like that before. I mean, doing a kind of by-encoder stuff. Should it be useful to remove, let's say, bad, which are not bad, token in this case? Not for Colbert, but for other ways to, which is not late interaction, but more representation-based dense models. Or
I don't get, for example, if we consider the single vector dense models, if you remove document token representations. So it is a little bit like the final perspective, which we say that this kind of pruning can be extended to not for the late interaction models, but to the early interaction models. Because if you remove some of the tokens, we could have a shorter context length, so it is much better for the effectiveness. And what we are thinking is only for the early interaction models, because it requires interaction, and our work is based on the interaction between the documents and queries. So we try to test if the document tokens could be matched with the given query tokens. But for the single vectors models, I haven't think of it. But it could be interesting if we can design some from a mathematical prompt of view that the generated identifiers will be not useful. But it is a little bit like the idea of the for the input, do some pre-processing of the input, for example, removing the stop words and then generating the event first. But I think given the previous work, we tries to doing the stop words removing for the neural IR, I think doesn't work really well. I think the neural IR also based on the transformers, they have with this kind of stop words or with this kind of punctuations, it works really well. So I don't think for that kind of thing it is very necessary. But for the effectiveness, I believe that we can indeed try to see if it is we can remove some of tokens to keep a good performance. It is something we also can try.
Okay. But I agree with you. I mean, it could be quite tricky with the math, I suppose. But okay, yeah, okay. Thank you. Now, I mean, okay. My last question is much more open. So, but okay, I'm here also to ask some kind of question as a colleague. If you had, let's say this, that's not. Okay, just to know your point about this. Keep cool. There is no trick or whatever in my question here. If you had, let's say, 2 years of project, I mean, okay, funding for this, okay, to extend or to transfer your work on RAGs, okay.
Yes.
What I mean, regarding what you did and what you are presenting here, what do you think should be the first point to be studied? To transfer some of your work to RAGs. I know you did put this in your conclusion and so on and so on. I agree, but I mean, I am asking you right now, what could be the most interesting or the most potential-wise aspect of what could be the most interesting for your point of view?
From my perspective, retrieving to the RAG, what I'm interested in is multimodal retrieval. That you can try to alleviate this kind of assay latent for the retrieval, not only for the text, but for the cross different languages, across different modalities. So it can have a lot of applications for the real cases, for the real industries. And I think it's really doable because one assay latent that for one same latent for different modalities, for example, for the text describing the bank, for the images that describing the bank, for the audio that stay in the bank, it can help the model to have a better performance. And we only need one dimension rather than various semantic effects. So I think that's a first direction I want to try. And the second direction I want to try is related to pruning, because I think currently, although in Thesis we didn't do too much interpretability test, but I think this kind of token pruning to understand which tokens is important for the LLM generation is very important, and it helps the communities to better understand what is important for generation to make the LLMs generate the important tasks. For example, if you remove one of the information, or if the information is not preserved once, it appears only once instead of two, why does the LLMs cannot generate a good answer is also an interesting direction. So it is interesting.
Okay. Thank you very much. And okay, I mean, I do not congratulate you yet, but okay, it will be in 1 hour maybe. So okay, thank you very much for your talk and for the answers to my question. Okay, I give back the microphone to the president.
Thank you. So we are now moving to the rest of the jury, and we are continuing with Sham, please.
Okay. Hello. Thank you so much for the nice presentation and for the nice dissertation. I really enjoyed reading it. I think you did a great job presenting your work. You did a great job presenting negative findings, which are often hard to present, but I appreciate it. And I found, especially your presentation, I think you're a very skilled presenter, and it came across very, very nicely. You put together beautiful slides. So thank you all for that. I have several questions. If I didn't have questions, I wouldn't be here. The first figure in your dissertation, and I think also this first figure that you listed in the slides, was the spectrum between kind of dual encoders, late interaction, and interaction models. Right?
Yes, this one, I don't know, it should be this one, I guess, this one.
Yes, there we go. Kind of on effectiveness and efficiency trade-offs between these classes of models.
Yes.
An omission on this figure is Gen IR models, right? Which
Yeah,
was
I see that, but, yeah.
a large focus of your dissertation. How do you characterize Gen IR models within this spectrum or within this framework?
I think it should be at still here, because if for the traditional Gen IR models, not the referential one, because for the referential one, if it works, we still need to build an index. But for traditional Gen IR, such kind of models is to say we don't build an index, we just store the index as the parameters of the generative model. So it is more efficient because we don't need this kind of indexing building stage. And it is just we train a model and then we just try to generate document identifiers. But it is very hard to generalize, that's what we said, because if a document identifier is unseen previously, it will never be known by the model and it will fail to generate it. I think because, and here we mentioned, we mentioned that there are kind of two types of arbitrary identifiers. The first one is arbitrary. It is really hard. For this kind of task, it's really hard. But for this kind of based on the metadata, it is easier. But it's still for this kind of things. It is based on kind of constraint training. So it need to make sure that the generated identifiers is really exist and it corresponds to a document. So this, from this perspective, still contains a kind of index in this case. So what I want to put is over here. Is over here, something like this.
Okay, so it sounds like you see there as a kind of a fundamental limitation of the effectiveness compared to these other classes of models there. At the trade-off of potentially more efficient.
Yes.
Okay, cool. Thank you. If we want to move on to the SAE splayed work,
okay.
I found this direction really interesting and really compelling. And good luck on the current submission. Hopefully that's a positive response in a few weeks.
Yes.
So one of kind of the most another kind of interesting contribution within the learned sparse space has been this wacky weights paper from McKenzie et al. Right, where they found that many dimensions end up being generated in nearly every document, almost like a pseudo dense representation for each.
I read that paper
for each document. Do you think that SAE Slade has that same kind of wacky weights problem here? Do you think it's often generating the same dimensions here, or is there something about the architecture that prevents that? And did you test this?
Yes, we did some tests for the MS Marco dataset, where we try to see the kind of representation of the models based on the longest post length of these tokens, and we found that the longest is around I don't remember the exact values, as I think it's around 800K, given the core corpus is around 8 million.
So 10%.
Yeah, so it's first present, but for the original splay, it has the longest one is around 2 million. So
right.
So we test is that indeed it is better.
So you're mostly not susceptible to the
yeah. But
why do you suppose that is? Like what about SAE Slade kind of prevents that?
I think it's just because they are based on the latency rather than on tokens. So for the representations that replies to the ease or to the contextualized representation for context input token like ease or for the stop words, they would rather put the weights on their SAE latency, for example, to the context latency rather than it's just this token. So it can be removed.
But doesn't the wacky weights paper make the argument that, sorry to go too much into the weeds, but I think the wacky weights paper makes the argument that it's treating these stop words like latent dimensions, right?
Yes, maybe. And but in our SAE, we don't encounter such, and we try to interpret this kind of, for example, the 80K, the documents that activate the latents that activate 80K, and we don't find too much, but they still the activate latents. It activates but it is very hard to interpret what, because we have 80K, so it is not easy to go into each document into detail to see what it is really corresponding to. But for the SE latents, for the splayed models, there are, for example, the top 100K for the latents which activate 2 millions, it is about the stop words. So, but we don't know for the 80K it really is corresponding to the semantics that's related to stop words or something else. And it is hard to explain in this case.
Okay, cool. So also in this chapter, you introduced the E-square measuring,
Yes.
which combines efficiency and effectiveness together into one, which I found really nice. I enjoyed being able to kind of have this direct comparison between the trade-offs. But what concerned me a bit there was the parameterization of that metric, right? So it has 4 parameters.
Yes.
And in the dissertation, you mentioned you selected these parameters. How did you select these parameters? And do you think the conclusions would change if you chose different parameters?
Actually, this is value. I remember this value is a little bit different from the previous dissertations versions because it is new proposed to adapt it better, because for the dissertation with the proposed matrix is not exactly as what we want. So here, our idea is that we want to have some trade-off between the effectiveness and efficiency. So for soft plus, you can just think it as a smooth value function. So when it is smaller than a certain threshold, it is just a 0, and after the threshold is linear, we can consider it as linear. So our goal is that to see that at the beginning of certain threshold, for example, before here, we try to make it almost linear. So we trade for 1 point on the QD flops to 1 point on the irrepressible rank. And here we just argue that, for example, after with QD flops, which is smaller than 3, we think that it is enabled for the real-time application. So we say that we can always keep this kind of trade-off. So for example, if we keep it to larger things, for example, QD flops larger than 5, we argue that it is not possible for the real-time application. So if we want to keep the same models, we need to have a huge gain on the effectiveness rather than a gain of the efficiency. So that's why we make it go smooth and almost linearly at the early stage, and then go exponentially large. Not exponentially large, but it is going large with a higher coefficient, which is the beta P1 minus P2 here.
Right. Okay. So it's based on operational constraints that you feel that kind of 3 is the top QD flop.
I don't remember.
5 is the right. Okay.
I don't remember the exact value, so I think tau is set 5 or 4, something like this. But it is a value.
Okay. If I was an adversarial researcher, couldn't I just set these parameters in a way that makes my research look great no matter what, right? Isn't this a bit of a risky measure just because of that?
I don't believe, because I think there's I checked the papers of the recent split models or sparse models. They are how to say their evaluate matrix. They are for the QD flops. They are just very smaller than 5. So that makes, and if we use the values very large, so we just want to throw it away directly if QD flops. For example, here for these models, I don't remember here. For these models with QD flops is 12, so we just don't compute this one. So we argue, although we compute these values, but just for the complementary of this table, so it is very difficult to constrain that to consider, and so we just throw it away.
Thanks. If we want to move on to the next chapter, I thought that the pruning strategy overall was really compelling, but what was extra interesting to me was the norm-based pruning strategy.
Okay.
And I think this fits a lot with my intuitions about what dot products end up capturing in terms of magnitudes and direction of the vectors.
Yes.
Did you try any kind of different pruning thresholds for the norm base? Because you used 0.5 as the kind of primary thresholds.
Yes, actually, I have a additional page, but I don't know. I've highlighted. Maybe I can show it here. Sorry for the distential one, but the files. Just wait a moment. No, it will. So I will try to give this page. I'll hide that page. Okay. Share screen. Okay. So here it's just an example of the pruning where we try to use different regularizations and based on different pruning ratio on different pruning strategies. And we find that indeed our models over here, we find that based on the same pruning strategies, the method based on document similarity regulator achieves a better performance. But the key point is that based on norm-based pruning, it can, when we try to prune more, it will have a better performance than the LP-based pruning. So which means that the non-pruning might be more robust. But the key point is that for the LP-based pruning, for the LP-based pruning, it doesn't work well if the model is trained with a L1 norm representation. So it means that reducing a norm, it cannot fit well with the LP task, which is more close to the semantics or the definition of the dominance. But if we, yes, indeed. But another point is that based on our new proposed method, which is based on the non-total method and based on the pruning based on the empirical pruning matching, it performs better than both of the non-based pruning and the LP-based pruning. So,
okay, excellent. And then my final question is kind of looking at your dissertation at kind of a higher level. What do you think your most important or impactful or interesting finding of your dissertation was?
I think just this one and this one. And for this one, we propose a method that is not relying on the vocabulary, because currently the LLM models, the learned sparse models, they are still trying to based on the vocabulary. For example, for the works that try to alleviate the multilingual, or for the multi-cross model, they are still try to relate it based on the lexical terms. For example, for the medical work, it is just still, although it tries to solve the multilingual, it still tries to do some kind of alignment of the original vectors into the English lexical representations. So it is still a constraint because it is still relying on English. So if there's not this kind of information is not really good represented in English, this word doesn't work. So I think relying on the sparse autoencoder is one kind of direction to alleviate such kind of problems, and it is a new direction and it's a new perspective that can be going on to this direction. And for this kind of token pruning, the most important is that we propose a theoretical things, that is to remove the tokens rather than based on statistic one. So we try to formalize the ideas of token pruning rather than the previous one, which is relying on looking like this, removing the norms, it works, but why it works, doesn't really know. So, but yes, I agree that the norm-based pruning, yes, it is a very interesting idea, because if you continue to add a regularization to reduce the number of vectors, once it is not used in a lot of cases, it will not contribute to the corpus scores, but the L1 regularization still contributes, so the norm will be very, very small. For example, for our norm-based pruning, what we found is that the most of the document tokens, the remaining tokens have the norm larger than 0.9. And for the pruning tokens, they have a norm smaller than 0.01.
Okay.
So that also makes this here. There's a huge for example, over here there's almost no performance drop if we go from pruning from 10% to 20% to 30%. Yeah, that's true.
Okay, thank you very much.
Thanks.
I pass the mic back.
Thank you. Now we're moving to Jamil Seda.
Thanks. Thanks for inviting me to be part of your jury. I found your work very impressive. Actually, the amount of work that you've done, was it 3 or 4 years, three and a half, something like this? is kind of amazing because on your thesis you had basically 4 main papers. Still you had the time to work a lot with some other colleagues and have 6 or 7 other papers on related or slightly adjacent topics. So my first question, how do you find the time to do all of this?
I don't know, actually. I don't know for this one. I just
There was some paper, obviously, that you did in collaboration with some other people that could have been in that paper. The one about the adaptation of the SIE and this kind of thing. The one that you submitted to
Yes.
journal, Springer journal, something like this.
The previous slide paper? Yeah, it is with Matthias. Thank you, Matthias. And that paper is more related to something like the cross-domain adaptation, and it is not of the domain of my thesis. It is more related to Matthias, which try to study the interpretability of kind of interpretation for the cross-domain, something like this. So, but we are joined because at that time I'm very familiar with this kind of models. I'm reading a lot of related work, so I can help to do some coding and do some
You
kind
brought your expertise that you're
Yeah.
here on that.
Yeah.
Right.
at that moment, yes, but kind
That
of
maybe
maybe.
be nice to add on that list a quick parenthesis with your contribution, something like this. Usually people do that, and it helps to gather the real scope of your contribution.
Yeah, I just do a very short scenes at the final stage, but oops.
No,
Oops.
sorry. It's okay, don't worry. It was super fine. And something which is a bit incidental that I told your supervisor before the thesis is that obviously you didn't use ChatGPT or Claude to write your thesis, and it was refreshing. And keep that in mind, other future PhD students, that for us who are used to read a very smooth thesis, they are boring, and yours was not. And thanks for that. But I have a couple of questions because I am not a specialist in.
Sorry, I just need to make sure that they are connected because I don't know.
We must then.
Sorry.
Okay.
Just to try to make they're connected, but I don't know where's the Zoom here. Yeah, sure. I think I have disconnected.
Well, let's ask. Can you hear us still?
Yes.
Okay.
Okay, that's good.
Okay. But I don't.
Yes,
Can you see the screen?
I hear you.
Can you hear the screen?
Can you see the screen?
No screen, yes. No,
Okay. No screen.
no, I mean, no, we see the amphitheater, but not the screen.
Okay.
Maybe Linda sees something, but I'm not sure. No,
Let's try to see what.
does not have a mic on anyway, but
How about you move the windows from 1 to 2?
I don't know because I can't see. Okay, it's there. Because it's been a long time that they didn't use a Microsoft really.
We have to show the current eventually.
It's coming apparently.
And,
Yes, we.
Good.
It's the hardest problem in computer science.
Yeah, I think that's
Okay, well, mainly we see.
We used to it.
And, can you see the screen now?
We see your screen plus your comments probably.
Okay, it's not
Probably
good.
not the public.
You need to share something else. Should be this one, I guess.
We'll see.
This one is okay.
Yeah, amazing, done. Right. Thanks.
Sorry.
Reading your thesis, I was, as the other said, I was really impressed by the way that you didn't hide your the failure of your models, and there was some kind of a progression, in trying to cope with this, and I think it was super nice and refreshing. You didn't hide being behind numbers. And regarding the comment from my colleague about that table with zeros that you hide, I get it.
Yeah.
Maybe you could have put it in the appendix, let's totally be honest. Something like this. But I understand. Don't want to have like a sparse table.
Sparse tables.
I get it. So, as I said, I was really impressed, and I was also full of hope. So when you introduced the whole SAE slide, I was hoping that because you are not relying on lexical items, you would be able to generalize more. And your results are a bit counterintuitive because you said that you didn't have good results in the out of domain data set. And this I don't get, because when you showed the example of the latent with all the words they cover, they seem pretty generic to me, and they seem somehow able to give some more generalization. So do you have any intuition about why it didn't really work on OOD?
Because for the OOD, I think that's why the split and the latent interaction models like Colbert does well. Because if there's a concept which such models doesn't see, for example, for split, for example, there's 3 letters which build an association with 3 letters. So you have to encode this. I assume that this kind of entity is never seen during the training. So the split models will try to activate at least for such kind of representations. For example, for the lexical term n, it will activate the lexical term n, and it will do the same thing for both the query and documents. So which means that this kind of lexical matching will be useful because the query representation contains this lexical term, the document token representation contains this lexical term. Both don't get a match. But for the dense models, like based on a sparse autoencoder, if this kind of thing is never seen, they will not know which domains it belongs to. It may generate identifier 311 for the query side and generate 33 other things on the document side, so there's not match.
So there is no techniques to handle, let's say, unseen concepts, because in old school NLP, when we were using, let's say, brown clusters or latent Richel, etc., in order to be able to handle unknown words or unknown concepts, the trick was to replace every word that was whose frequency was lower, let's say 3 or 4, by a special token, which would then be captured by the model. And sometimes you want it to be more clever, so you add some kind of special suffix to say this is a number, this is an adjective, this is a word. And so this allows the model, so this is basically the ancestor of what you're doing, to be able to generalize. And so there is no such technique for SAE and learning and to learn this.
No, as sparse autoencoder is just learn to reconstruct the input vectors as because currently in our case, we just train our models as sparse autoencoder based on the MS Marco dataset. So it's not a full corpus, and this corpus is not that big. So that kind of things, unseen latents for the out of domain, it really exists. So our goal is just try to see if it kind of can alleviate such kind of problems. So different from the previous work like Splayer, which is use of pre-trained language models, we don't know which kind of corpus they use for training such kind of sparse autoencoder. So they cannot study this kind of interpretations between the out of domain. So it is one of the key component which is our work different from the previous work.
Okay, cool. So also, as I said, I'm a bit of a naive researcher on this domain. So let me know if I'm saying something too stupid to be answered.
Don't worry about it.
Recently, a couple of months ago, even a year, there has been some work in LLM modeling coming from the Tencent lab, where they try to train an LLM on consecutive sequence of tokens. Instead of just one token, they try to learn that this sequence of tokens, token 1, token 2, token 3, actually consisted in some kind of concept, like a multi-word expression, like in French, we say pomme de terre, which is basically a couple of words to say potato, But when you do retrieval, you're not having this notion of basically lexicalized unit of lexicalized sequence of tokens. So do you think that in this field, in what you're doing, there could be some way to do it? Because when we looked at the tokens that you capture with the SAE, some of them were obvious, like BP split. Some of them were part of something else. Do you think it could be possible to not handle things at the token level, but at the sequence of token level?
I think it's possible, but from the perspective of a sparse autoencoder, I think it is very difficult because it tries to interpret at a level of each contextualized representation.
Go beyond the sparse autoencoder, just for what you've done in retrieval. Do you think it would be something that people would like to see, or something doable, or there is no way because those collocations basically will be captured anyway?
Yeah, I think it's possible. I think we can first relate this kind of research question to the name entity recognition. So we first do the name entity recognition and then um, apply such things. I think it is possible. And I think from this kind of perspective, we can also try to do something more fancy from our perspective. For example, we can, sorry, I go back to the spots of encoder, but the key problem is that we can do, for example, we can do some kind of token pruning, and we can do it with our false method proposed. And then we just remaining the last tokens. And then we assume that this last tokens is no longer, for example, bomb the def. It will not only contain semantics of all the def only, but it already contains semantics of the bomb the def. And then we apply such kind of sparse autoencoder on top of it. So it can be captured only with the concept of the potato concept instead of the world or the ground concept. So it is something which we can do, and it can make the retrieval more efficient and it's more effective.
Okay. Like, do I have another question? Otherwise, so like detail. For example, I didn't understand why your Hotbert model didn't work, and you had to switch to Colbert for the token pruning. You said that you tried to do the pruning with Hotbert,
Yes.
and it didn't work, and then you had to switch to something else.
No, because we just say that because the Hotbert is a model which doesn't work. So, and the Colbert is a very mature model. So we can start to evaluate our proposed method. We can start from the Colbert checkpoint. We can do something and we can compare with other models, which is also based on Colbert. So that's why we propose starting from the Colbert rather than Hotbert. And Hotbert doesn't work means that we cannot build a model that works. So it is not direct comparable. So think so.
So it was like a clean base.
Yes, start from a clean base and have a good starting point at least.
Okay. So I don't have any more interesting questions. So if there was a way to So thanks a lot again, and congratulations for all the work you've done.
Thanks. Thanks a lot.
Thank you. I will ask a few final questions. I'm also not a specialist in information retrieval, so if I say something stupid, maybe there's just
no, don't worry, no worries.
So my first question is going back to those methods that didn't work in the end, because I think we were all super surprised by that because they are very well motivated. I mean, you reading the manuscript. I'm thinking, oh yeah, that's a nice idea. That should work. Oh yeah, that's nice.
Exactly.
That's very sound. And then oh no, it doesn't work. So my question is a provocative one, and rest assured the people from the IR community are not listening to your answer. What if it's just generative IR that just doesn't work? What if it's just not the right framework for the task?
You mean
in general?
You just the traditional generative task or IR task or for this task?
Well, a generative approach to information retrieval is maybe not a good approach, and that's it. Right?
Actually,
on that.
During the years of the conference, I have indeed discussed with some people who are doing this, and indeed, I don't know if Sean also mentioned that there's less and less papers about generative retrieval methods recent years on the CIR. So showing that there are indeed a dropping of interest into this domain. So maybe it's due to what we described, the problems of the generalization, the problems of the how to adapt to larger data set. But there are still some groups we still trying to work on this direction. I don't know if last year there's a work which I presenting the reading group is that they argue that the generative retrieval has some benefits compared to the dense models because they are doing such kind of soft cross entropy loss. So their mapping is a global mapping instead of the single mapping because they try to maximum the given a fixed one instead of leveraging the contrastive learning. So from this kind of perspective, it indeed has some limitations. It indeed have some benefits, but from my perspective, their limitations is larger. But if we, for example, in our final general perspective, if we try to reframe this kind of generative retrieval into a different kind of things, it might have some other directions we do. So from my perspective, I think that directly generating the direct identifiers and using the direct identifiers to match what we have based on the existing identifiers, this direction is already to how to obtain to get rid of this generation ability and the problems of the smaller data set adaptation task.
Okay, and regarding the methods that you propose and explore, I have the feeling that maybe it's just too hard because it's not supervised enough. For example, here you have a hierarchy that is not entirely leveraged in terms of supervision, right? And it shows that you say it's super hard to optimize, and then, of course, because it has a lot of symmetries or a lot of solutions that would give the same answer and so on. So would there not be a way to make it work by over-engineering it, by adding more supervision and constraining the different levels of the hierarchy, or having a sequential training scheme that would, expand the hierarchy or that kind of stuff that would be more hands-on rather than, letting the model figure out.
Actually, in this work, we after looking back, is that we found this kind of training objective is a little bit like the current state-of-the-art reinforcement learning metric like DPO, which just to try to compare two documents if one is better than the other one. And so based on this, our idea is try to see if we can do some generative like training first and then apply our methods. But for our experiment, it doesn't work, and we argue it is mainly because the generative retrieval, they still tries to do the one-to-one mapping. So this kind of, it will make this kind of one-to-one mapping scenario more often in the case. So it is not what we want. So we just do some little try. If that works, we don't go further. So
yeah, that makes sense. Okay, yeah. If I move to the spatio-molecular stuff, you spend a long time and many experiments on the number of concepts that are keep activity, the K value, and you don't talk much about the total number of concepts, the M.
okay, sorry.
And I was wondering if that's not a more important setup, right? Because you want something that is ultimately sparse, but if the total number of the total dimension is very small, of course, you won't have a lot of collision. If it's super high, you can make it as fast as you want, but then nothing matches to anything, right?
Yeah.
So I was wondering whether that dimension here is not how much of a critical parameter is it?
Okay, just to try to sorry this part because we decided not to speak that much, but for this part in detail we have some analysis onto this value M over here. So for give an example for the traditional split models, which is based on M head, the vocabulary is around 30K.
Yeah.
And for our case, we use M is due to the kernel we design, we have to use the power of 2, so it is around 2 to the power of 16, so it is around 65K.
65K, yeah.
And yes, indeed, these two dimensions are not the same. But what we encounter is that during the SAE training, for the SAE training, there's a very important concept which is called dead latents, which means that the number of latents which will never activate during the training. And we found that during our SAE training, it has almost no dead latents. But if we switch back to the split mode training, it will generally increasing this kind of training ratio to around 40%, 30%, something like this. So to enable a fair comparison between the SAE split and the traditional split models, which we want to remain the similar level of the dead ratio latents, similar level of total latents which is activate. So we propose M equals to 2 to the power 16, but also we try to vary the numbers. For example, to propose the S equals to 2 to the power 15 or to the power 17. And we find that increasing the number of vocabularies, it don't change too much the performance. But for example, for the 2 to the power 17, it have around 50% of that ratio latents. But it means that there's more because the ratio is the remaining one is such a ratio multiplied by total numbers. So we have more latents to be used, but more latent to be used doesn't transfer to the performance gain. So it is something which we found.
Okay.
So it is not that important factor.
Okay.
So we don't present here.
Okay. Well, maybe one very last question. If you can go back to this slide 51, which is in fact, I think
Sorry,
which is
what we thought.
it's towards the end.
Yeah. Okay.
Um,
Okay.
here, which is the example for the token payment. So here, the linear programming approach is able to move later occurrences of some of the concepts. And but he said that TLD is very costly to run, and there's not satisfying solution for that. To me, when you present, I didn't thought about that really in the manuscript, but when you did the presentation, I was thinking, oh, that looks like something like a causal model should be able to do.
What model?
A causal model, an autoregressive, like an LLM type of model, right? You give it the thing and you say, hey, I like the best words from that sentence, and because not doing a repetition is sort of an easy task for a model.
Yes.
So I was wondering whether instead of finding handcrafted ways to uncover those concepts you could not learn directly, a model that would, parse the text in one go, or the tokens or the representations in one go, and then answer some kinds of binary. Should I keep it? Should I not?
I think that's just the traditional works like the LeapLM or the aligner does. It just learns a weight and multiply this kind of weight to the vectors and using this weight to print the tokens. So it is just what does the LeapMV does or what does the aligner does.
So you see, here comes my complete lack of knowledge in the domain. But is it autoregressive? Like you sample and then you get back to the next token, or
no, it is just given a contextualized representations, a set of contextualized representations, and then just adding a classifier on top of it to see if the token to predict the probability of this token should be removed or predict.
And then you sample from those probabilities. So you right?
Not sample, but it is just a predict. Threshold, yes.
Because I was wondering whether you could have a generative approach in that case, which generates binary variables, whether you took amounts, and then if you miss it the first time because of something, you still have a second chance to sample it.
Yeah, but yes, it is. Yeah, I think there's a direction we can go, but I still don't get too much of the intuition of using a generative model in this case, because generating such kind of first it will be more costly if we have a generative model instead of a simple layers. And for the simple layers, it is just a projection pad, and we can reuse the original token representations. So we don't think it's never necessary to apply an additional generative model to predict it.
Okay, so not a good use case for generative AI.
Sorry, I rejected, but just as it is.
Okay, thank you very much. That's all from me. A few words from your supervisor, man.
Yeah. Thanks, David. Well, thanks to all the jury to have come to Paris or attended remotely. Well, that's been quite a journey, I guess. And I think we met 4 years ago when you were finishing, in the middle of your master internship. And remember you said that you would never know more than me on IR. I think that after 4 years, that's something that changed. I mean, there are many works that you do know and I don't. Maybe there are some that I do and you don't also, I hope. But still, you made a lot of progress, and I congratulate you for this. I mean, you did quite a long path towards doing full-scale experiments, and you did quite a lot. I mean, you did an impressive amount of experimental work, including all the failures that are kind of filled half of your PhD almost. Maybe not a half, but at least one good third of your PhD, and still, I mean, it was. I know it was hard. Maybe it was the wrong direction. Maybe we didn't succeed in making them work. I don't know. There is no definite answer, and that's why negative results are hard to expose, because you never know whether you were almost there. And we tried, and that's why it took so long to say, well, okay, let's switch to something else. And luckily, we did. So well, I want to congratulate you for the remaining of your work on SE speed and for that, where we succeeded in making things, maybe simpler things work, but still it was quite good results and quite good work. And so thanks for all this and all your energy and your thesis. It was I appreciated this.
Thanks.
I always wondered if there was a camera in my office because you have, I don't know how, a way to know when I'm about to leave the office and to come in my office just 5 minutes and just wrapping my stuff.
I don't know.
And just asking a simple question. I know, well, at the beginning I didn't know, but after a while I knew that a simple question would be at least half an hour or sometimes 1 hour more. But it was still a nice conversation. So thanks for this also. I think I will remember this. And congratulations again.
Thanks.
Thank you. Yeah, okay, so we'll now go
What?
Okay, so we now move
Or we move because you need to connect with.
Or we can stay here.
You can stay here because.
Okay, so then we stay here and you have to move. Everybody has their desks.
And we'll meet in the camp.
Yes. What?
We meet in.
Or meet here or actually okay.
Okay, so I just send you a message.
Okay.
Good.
I need to take some water.
I'm back in 1 minute. I'm back.
Nice. So this is half of the yes, it depends on chapter 4 the system.
I don't know.
I think I remain something here.
Solution.
What?
Bibliography, I mean, it's missing part of the real part of the pages.
What?
It ends here with a CX place.
It's not the same that we get. Yeah, it's missing 100 pages.
I don't know why.
No, that's good.
Okay.
I don't know.
Don't worry.
I don't know. Maybe I set a maximum length of 100 pages for
Because
the.
you had 188 pages, and I think you have like half of that.
Yes.
Yeah, it stops at 100.
I don't know. Maybe I need to justify this with a report. Yeah.
As a repro of the university?
Yes.
Okay. Maybe they were short on budget.
Seriously, be careful because when you'll be sending your thesis for final approval, you don't want your thesis to be like half of it.
Yes. Yeah.
Okay, well, I guess PDF size is okay.
Yeah.
Yeah.
Maybe for the latex mistake or overleaf or something.
No. I just send the PDF to the report and we go.
But double check, friend.
Okay. To send. Okay. Definitely.
I don't know if you have to send still a hard copy anyways.
I don't have to get it. Sorry. There you go. Okay.
It's not true.
Tu fais des flux, tu enfin
Je fais une anecdote. Je fais des trucs du semestre.